academic heights? Learn from home. Why academic heights? To get clarity in understanding, clear concepts, basics as well as core concepts for your future competency. Overall, your journey starts from here. I am ready to teach you. Are you ready to learn? Let us start today. Short answer type questions, 2 marks. 27. Already I have covered 20 to 26 in one of the video. I will give the description above. Please go through it. So 27th question. Find one rational number and one irrational number between root 3 and root 5. Very simple question. The twist is here. Writing irrational number. Writing irrational number. That is the twist. But suppose the concept here it is. Suppose A is a number. B is another number. To write a number in between. So he is asking in between. So how to write in between A and B? So that is as simple as that. You can write A plus B by 2. So this is the number is always in between B as well as A. So what is the number? We have to write it now. A plus B by 2. So he is asking one rational number and one irrational number. So we can get irrational number. So root 3 plus root 5 by 2. Root 3 plus root 5 by 2 is example for irrational number. Next, how to get a rational number? How to get a rational number? So clearly we have to think about it. Root 3 is less than 2 definitely. Yes, because root 3 less than root 4. So root 4 value is how much? 2. So root 3 value is less than 3. And root 5 value is more than 2. Why? Root 5 is more than root 4. What is root 4? It is 2. So root 3 value is less than 2 and root 5 value is more than 2. So here clearly we can write one of the rational number is 2. So 2 is a rational number, is an example for a rational number. So you will get 1 plus 1, 2 marks for this question. Anyhow, this is a 2-mark question. So what is the logic? If A and B are the two numbers, how to get the between number? So that is nothing but average of those two numbers. So I wrote the average of these two numbers here. This average will give the answer for you. So based on this logic, I got the rational number, irrational number. I got the irrational number. After that, rational number. How to write the rational number? So this is the concept I have used. This one. Root 3 is less than root 4. Means root 3 is less than root 4 means root 3 is less than root. Why? Because of root 4 value is. So root 3 value is clearly, it is, if I write this root 3 value, it is 1.7. And root 5 value is nothing but 2.6 and so on. Is an irrational number. Neither terminate nor recur. So between 1.7 and 2.2 we have many irrational numbers, infinitely many irrational numbers are there, but he is asking one of the irrational number. I wrote one and one of the irrational. So that's all from my side and about this problem. We'll move to the next question. Very good question, which is not in your textbook. So first find the HCF of these two numbers. You will get something number. You will get something number. Suppose I am taking it as something A. A. If you find the HCF of these two numbers, you will get one A. So this number you have to express it as 13m minus 3. Indirectly, he has given that A is equal to 13m. We have to solve this equation. So I told the logic here. Find the HCF of these two numbers. Suppose you are getting A as HCF. This is A. We have to equate this A. We have to equate to this number and solve it. So let us find out. So I will go for first step. It is step 1, that is HCF. So find the HCF. Here 180 is more than 144. So I have to divide 180 by 144. So how many times it goes? It goes by 1. So 144 ones are 144. What is left out? So I can take borrow from here. It is 10. So 6 I can write it here. It is 7 minus 4. 7 minus 4 is 3. 6. So this division will continue until you will get 0 as a remainder. You know that HCF, how to find the HCF. So this division will continue. So this remainder, now I am taking it as a divisor, and earlier divisor I am taking it as a dividend now, and continuous. So 36 2s are 72. I think 36 4s are. So 6 4s are 24 and 2 is left out. 4 3s are 12. 12 plus 2 14. 36 4s are 144 I got. So at the end it is terminated. So the division process is stopped. Then what is HCF here? So when we got 0 as a remainder, when we divide with the 36, so therefore your HCF is 36. Your HCF is 36. So this is the process how you will find HCF by division. Next. So anyhow, this is a 2-mark question. We got already 1 mark here. Next we are moving to the step 2. Step 2, it is very, very important, and it is very easy also. So this 36, whatever I got HCF, I have to equate to this one, equate to this expression. So 13m minus 3. So why we have to equate? He has clearly given if HCF of these two numbers is expressed in the form of 13m minus 3. So we have to equate these two values. So minus 3 you can take to this side. So this becomes 36 plus 3, that is equal to 13m, and this is how much? 39. 39 is equal to 13m. M is equal to 39 by 13. Here 13 is multiplying here. Here 13 is multiplying here. If it comes this way, divides. So 39 by 13, that is nothing but m value is. So we got m value as 3. He has given this m as a variable here. So he is asking the value of m. Find the value of m. It's nothing but 3. Value of m is how much? So for this question, we have adopted 2 steps. First step is finding HCF. Second step is HCF is equating to the expression. I hope. Next question. Find the value of minus 1 power n plus minus 1 power 2n plus minus 1 power 2n plus 1 plus minus 1 power 4n plus 2. where n is a any positive, here it is an odd number. So corrected, this is odd integer. So what is n? N is odd positive integer, odd as well as positive integer. He has given this one. N is equal to any positive odd integer. So you know what is odd integers. So for n, it takes value 1. 1 is the odd integer. 3 is also odd integer. 5 is also odd integer, and so on. You know what are the odd numbers. Now, for this question, if you keenly observe the powers, here we have n, here we have 2n, here we have 2n plus 1, here we have 4n plus 2. So when n is odd number, so first power, I am writing n, first power, and third power, these two terms, 2n plus 1. When n is odd, n and 2n plus 1, definitely this is also odd. This is also odd. What about remaining one? Remaining powers, you can check it. Remaining the powers of this term and this term. So when n is odd, so 2n and 4n plus 2 is always, this value always even number. So how it is even number? How it is odd number? Simple. If n is odd number, definitely 2n plus 1 is also odd number. So substitute any odd number here. Substitute any odd number here. Suppose 1, 2 ones are 2, 2 plus 1, 3, odd number. Substitute 3, odd number. 2 3s are 6, 6 plus 1, 7. 7 is also odd number. So n and 2n plus 1, is always a odd number. 2n and 4n plus 2 is always a even number. So can you give one example? Here you can substitute 3 here. In the place of n value 3, substitute odd number, substitute. Odd number is multiplied by 2. Odd into even, always even number. And here also you can substitute 5. 4 5s are 20, 20 plus 2, 22. So even number. So based on odd even, we can solve this expression. We can find the value of this expression. Simple. Earlier already you know that one. Minus 1 power odd. Minus 1 power odd. This value is always minus 1. Minus 1 power even. This is always positive 1. So what I got here? So minus 1 power, I'm writing the expression minus 1 power n plus minus 1 power 2n plus minus 1 power 2n plus 1 plus minus 1 power 4n plus 2. So what I got it here, simply this is odd, minus 1 power odd, this is odd, this is even, this is again odd, and this is even, 4n plus 2. So this is again even number. So minus 1 power odd, this value is how much? Minus 1 power odd. Minus 1 power odd, that is minus 1. This is minus 1. This is also minus 1. Next, minus 1 power even number. This value is how much? Positive 1. So I am writing positive. So here also even number, minus 1 power even number. This is also positive. So what I got ultimately? Minus 1 plus 1 minus 1 plus 1. Minus 1 plus 1 get cancels, minus 1 plus 1 get cancels. What you are getting ultimately, the answer is 0. So what is the value of this expression? This is 0. So before solving this sum, you can correct it. This is a odd positive integer. Here you have to correct yourself. Odd positive integer. I hope it is clear to everyone. Question number 30. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So how to solve this question? This question we have to solve by Euclid division lemma. Euclid division lemma. We have to apply the Euclid division lemma, then we will get it this sum. Easily we can sum. So here, what is Euclid division lemma? A and B are two positive integers where A greater than B. A can be expressed as BQ plus R, where R takes the value 0 to B, strictly less than B. So that is Euclid division lemma. Here same thing I am applying. Let consider two positive numbers. I am taking A is one number and B is I am taking a positive number as 4. Consider A and B are two positive numbers. Two positive numbers. So if I apply the Euclid division lemma for this A and B, so A is equal to what I can write it as 4q plus R, 4q plus R, where R we have to take the values where R strictly less than 4, it starts from 0. So this is Euclid division lemma statement. I have taken two positive integers and I have applied the Euclid. So here, whatever I got the expression, I can write different values of R in this expression. So A is equal to 4q plus R. Put R is equal to 0. I am taking R is equal to 0. So what happened? This expression becomes A is equal to 4q plus 0. A is equal to q. So further I can simplify in this way. This 4q I can write as 2 into 2. 2 into 2q is nothing but 4q. So ultimately what I can write is 2 into some integer. This is some integer. 2q is an integer. Writing it as 2k. So I wrote A as in the form of 2k. What I wrote? A is in the form of 2k. So this is a A is equal to 4q is a odd integer. But what I want this is a even integer. I want odd integer. So go for odd integer. So similarly, I can go for in this expression, I will put R is equal to 1. Put R is equal to 1. So what I will get it? A is equal to 4q plus 1. 4q plus 1. So I can write this as 2 into 2q plus 1. That is nothing but 2k plus 1. So I wrote this A 4q plus 1 in terms of 2q plus 1. So what is 2q plus 1? 2q plus 1 is a odd integer. 2q 2k plus 1 is a odd integer. So this is in the form of, so A is in the form of 4q plus 1. So that is our A. Now we have two more options again, two more values of r. So a is equal to 4q plus r. Put r is equal to 2. R is substitute r is equal to. So a is equal to what I will get it, 4q plus 2. So if I simplify this, I can take 2 common in the both the terms. If I take 2 common in the both the terms, I will get 2 plus 1 I will get. So 2 into something, I can write this as integer. Something I can write it as integer k. So 2k. So whatever a is equal to 4q plus 2, I wrote in terms of 2k. So what is 2k? 2k is nothing but a even form, even integer. Again I got it here, even integer. Even integer I got. So I cannot take this value. A is equal to 4q plus 2, I cannot take it. So why? Because of this is even integer. But the middle part, this is odd integer. This odd integer. This odd integer. I have to consider this number. So last one, in the same expression, a is equal to 4q plus r. So substitute r is equal to 3. A is equal to what we are getting, 4 plus 3. So this is nothing but 2 into 2q plus 3. 2q, 2 into 2q. I can write 2 into 2q, and this 3 can be written as 2 plus 1. 2 plus 1. So what I can write this expression? So if I take 2 common, 2q plus 1 plus 1 I'm. So 2q, 2 times of 2q plus 1 plus 1 I'm. That is nothing but 2k plus 1. So this is again I got it as odd form. This is again I got it as odd form. Why? Because of 2k plus 1. So this is can be taken. This can be taken. Why we have to take? So the a value is how much here? 4q. So only these two are the numbers are odd integers. We can analyze that. So when a is divided with 4, when a is divided with 4, we will get some quotient and we'll get some remainder. When a is divisible by 4, when a is divisible by 4, I will get some quotient, I will get some remainder. So this dividend can be written as dividend is equal to divisor into quotient, plus remainder, plus remainder. So here r takes the values 0 and strictly less than 4. So indirectly r takes the value 0, 1, 2, 3. So if I write 0 here, put each and every value here, you will get a different value of a's. You will get different values of a. A is equal to 1 time you will get 4q. When r is equal to 0, you will get 4q. A is equal to 4q plus 1. A is equal to 4q plus 2. A is equal to 4q plus 3. Here this is an even integer. This is also even integer. So what is left out? Only these two left out. These are odd form of the integer. So this is the logic we have applied the earlier explanation. So once you go through it, very, very important. Next, last question of 2 mark questions. Let us see this question. 2 tankers contain 850 liters and 680 liters of petrol respectively. Find the maximum capacity of a container which can measure the petrol of either tanks in exact number of times. Exact number of. So this is the word very, very important. Maximum. Maximum. So when we'll have this word maximum indirectly he is asking HCF of 850 and 680. 850 and 680. So find the HCF of these two numbers. That will give the tanker's exact number of times, so we can measure it and we can fill it. So find the maximum capacity of the container. What is the capacity of the container? Maximum capacity of the container, find out. So here 850 is greater than 680, so that we have to divide 850 by 650. 680. 850 we have to divide with 680. So how many times it will goes? One time. 680. So subtract. If I take borrow here, it is 15. So you will get 15 minus 8 is 7. 7 minus 6 is 1. 170. So 680. So how many times it will goes? How many times it goes? 17 5s are 85. So it is, we don't have that much value. It goes by 4. 17 4s are, check it. 17 4s are 68. Yeah, it goes by 4s are 174s are 174s are 68. So here our division stops here. When we are getting 0, when we are dividing with 170. So HCF of this number, HCF of these two numbers, 850 and 680 is how much? 170. 170. This is the 170 liters. 170 liters container we have to take to measure this and this exact number of times. I hope this understood everyone. That's all from my side.